Kia ora. So in this question here, what we're looking at is the non-inverting amplifier circuit for an op-amp. And you can have a look now. Let's just look at the, see what's in the simulator. So what we've got here, let me just turn off some of this stuff to make it look nice and simple. What we've got here is we've got an input voltage on the non-inverting input, right? And we've got a voltage on the inverting input, which is coming from the output. So this is this negative feedback. We're saying that what we're taking is we're taking a proportion of this output voltage and we're getting a proportion of it from our voltage divider, and we're applying it here to the input. And then of course we know that what an op-amp does is it does the difference between these two and multiplies them and puts them on the output. So what we've got here is negative feedback. Some of the output is applied to the input, and this is how we control an op-amp. Okay, so what we've got here is we've got an op-amp which is doing something like, let's just have a look at this here. We'll find a nice simple voltage. Oh, I could see something really simple like 1 volt. So we've got 1 volt here on the input, and on the output we have got 11 volts. So we haven't got this huge amplification factor. Now what we've got is gain. Gain is what you've got when you've got an op-amp in a circuit with negative feedback. So it's not 100,000 or 1,000,000 or 10 million amplification factor, but in this case it's got a gain of 11. And we can work out that gain using the model for the operational amplifier in this feedback circuit. Now I've done that in class and I've done another video on it. So what I've put up here is if you want even a further little bit of feedback on how this circuit works and how this model was derived. I've already done it for you, but you know, if you want to look at another source, here's one here you can have a look at. But basically what you've got is you've got this voltage over this resistance over that resistance, plus 1 is our gain. Okay, so this is the non-inverting. In other words, as this voltage goes up, the output goes up. That's what non-inverting means. And the gain is 1 plus the difference in the ratio of these two resistors here. So we've got 10 to 1 here, so that's why our gain is 11. So let me see, as this voltage goes down, you can see the output voltage is going down, okay? Right, and that includes negative as well, because what I've got here is, say I've got minus 308 millivolts, and I've got minus 3.4 volts here. And the reason I'm getting positives and negatives is because, of course, I've got a reference point which is halfway between these 2 points here, and that reference point is ground. So I've got minus 3 with respect to ground and plus 3 with respect to ground. And here is plus 15 as our power supply input to the op-amp, and minus 15. So this is how we get plus and minus voltages. And here is our ground here. This is our reference point, which is 0 volts. So this is minus 15 compared to ground, and this is plus 15 compared to ground. Go back again and have a look at that tutorial at the beginning of the course if you need some more information about how positive and negative voltages work, okay? So now the thing about this is it's non-inverting. That means that as this voltage goes up, the output goes up, okay? So that's the non-inverting amplifier circuit. And it's got a gain of 1 plus the ratio of these two resistors. Hopefully there's a little bit of background information. You'll be able to do this now. Cheers.